Hi everyone, this is section 3.4, velocity and rates of change. This sheet that I have here is all of the different formulas that we're going to be using for this section. So you might want to push pause and write it down, or I'm gonna post all of my notes. I'll post them as a PDF on Classroom, so maybe you just want to print them there. But these are all the formulas that we're going to be using throughout this section. You absolutely should get your calculator out because I'm going to be reviewing some calculator things with windows, stat plots, etc. So make sure you have your calculator ready to go. Okay, so let's start with problem number 2. Okay, so that was the suggestion that was made. Please do some more of the problems that are in the book to help us with our homework. So problem number 2, you need to know the area and circumference of a circle, which I'm very confident that you know. Area is pi r squared and circumference is 2 pi r. And the problem asks you to write the area of a circle as a function of the circumference. So that means the area in terms of circumference. So first thing I did was solve for r. So when you solve for r in the circumference, you get r is c over 2 pi. And then I plugged that in. Pi, r is now c over 2 pi. So when you simplify that, you get c squared over 4 pi. Okay, part B asks you to find the instantaneous rate of change of the area with respect to the circumference. Okay, so in other words, I need to find the derivative. And the derivative ends up being c over 2 pi, and I will walk you through how I got that. So c squared over 4 pi is a fraction, so I'm going to use the quotient rule. So the quotient rule says the denominator, which is 4 pi, times the derivative of the numerator, which is 2c, minus the numerator, c squared, times the derivative of the denominator. 4 pi is a constant. Don't be confused. People see pi as a symbol and they think it's a variable, so just be careful of that. So the derivative of 4 pi is indeed 0, all over the denominator, which is 4 pi squared. So you simplify this and you get 8 pi c over 16 pi squared, 8 pi c over 16 pi squared, which does reduce to c over 2 pi. Let's hope that's right. We want to find the rate of change. This is part C, number 2. They want you to find the rate of change when c is pi and c is 6 pi. So I plugged in. If c is pi, you get a half. And if c is 3 pi, you get 3, I think. C is 3 pi. No, you should get 3 halves. I'm pretty sure that's wrong. If c is 3 pi, yeah, you get 3 halves. This is not correct. Look at that, erasable pen. Almost as good as a whiteboard. Yeah, okay. So the next question says to you, if c is measured in inches and a is measured in square inches, what units would be appropriate? And the units that would be appropriate, I'm having a hard time speaking, would be inches squared over inches. And normally we say, oh, you should reduce. But if you reduce, then there's no viable comparison. If you reduce, you get inches to 1, and that doesn't make much sense when you're talking about a rate of change. What happens when you increase the circumference, you are increasing the area by a squared measure. All right, so that's number 2. All right, number 6 is the next one I'm going to do, and take out your calculator. So if you don't have your calculator, you should go ahead and pause and get it out. So number 6 is a table of values. Number 6 on page 135 is a table of values. And the directions say, plot S versus T on coordinate paper. Why don't they just say graph paper? And sketch a smooth curve through the given points. Okay, so this is what I did. And I'm going to just move my notes out of the way so we don't get a weird focusing background here. Okay, so I'm going to put this into a stat plot. So stat, which is underneath delete, stat, edit, and then I already have all the information plugged in. Make sure that you're in list 1 and list 2. Make sure that you are using the, here, let me move this up just a little bit. Make sure you're using the negative key and not the subtraction key. They are different on the calculator. The calculator does note a difference between the two. So make sure that for every L1, you have an L2. So go ahead and plug this in. And I'm gonna wanna see what the graph of this looks like. So push pause if you need to. Quit. Okay, so I want to graph this. There's no need for me to plot points when the calculator will do all of it for me. So I'm going to do stat, calculate, and this is going to be a quadratic regression. Well, how did I know that? So sorry, let me go back a step. So I didn't know off the top of my head that this was going to be a quadratic regression. So I went to my y equals. I turned my plot on. You can ignore everything else that's in my calculator. It's for later. Make sure you turn your plot on. Again, ignore this. This is for later. And then you can do a zoom stat, which is number 9. And that's how I knew it was quadratic. So enter the data, stat, edit, quit out, and then do a y equals, turn your plot on. If you're getting error domain, you have the information plugged in wrong. So if you're getting error domain, chances are you plugged in, your lists don't match. You have a value in list 1 that doesn't have a corresponding value in list 2. Okay, so then what I did was, I'm like, okay, well, it looks like a nice curve, but I really want to see what it looks like. I want a clearer picture. So stat, calculate. Now I know it's a parabola, so I'm going to go down to quadratic. So either arrow down to 5 or push 5, whichever you're more comfortable with. Okay, the calculator will take the equation and put it where you need it. I'm using list 1 and list 2. Frequency list, I'm really not sure what that's for. Store, you want to store this regression equation. Alpha, trace. Again, alpha, trace. And I want to store the regression in wherever you want. Most people choose 1. So y1, it's going to calculate. Okay, there's your quadratic regression, which is perfect, by the way. Now go to your y equals, and there it is in y1. It should be 6x squared. I don't know why it does plus negative 18x as opposed to just minus 18x, but whatever. So now let's graph it, and voila. Okay, so that's a quick review. If you need to rewind, but that's a review of how you get the stat plot on your calculator. Okay, so then the problem asks you, which by the way, do you notice that I have it drawn nice and, hold on, sorry. See, I have it drawn nice and neat. Let me zoom back out. There we go. All right, so you should have a very nice, neat graph. Excellent. This is like the only time I can draw graphs perfectly. So if I can do it, you can do it. So the next part says, assume the smooth curve represents the motion of the body. So time, position. Make sure you have labels, time and position. And then they want us to estimate the velocity at t is 1, t is 2.5, and t is 3.5. Okay, so the velocity is the slope of the tangent line, which is the derivative. They all mean the same thing. Derivative, slope of the tangent line, velocity. So and I'm not gonna lie, I had a hard time with this one because I thought, well, they want me to find what's happening at 1, but I only know the point at 1 was negative, whatever they gave us, 8.5 or something like that, -4. So what you need to do is to find the tangent, or to find the velocity at 1, you need to know the slope at 1. Well, I don't have an equation. I mean, I have the equation on my calculator, but that's, you know, not, what are you supposed to do when you don't have your calculator? So we use the two values closest to t equals 1. So here's t equals 1. So the two values that are closest are when t is 0.5 and when t is 1.5. Those are the two closest values. So slope, derivative, velocity all mean the same thing. So the slope from 0.5 to 1.5 is -6. And then they ask you to find the velocity at 2.5. So at 2.5, I used the 2 points that were closest. So here's 2.5. So I used 2, -8.5, which was given, and I used 3, 3.5, which was given, and that is 12. And then 3.5, same deal. 3.5 was the same deal. Okay, and again, I will post the PDF. All right, now we're going to move on to number 10. Number 10 is the particle motion. So it tells you that P moves along a number line as shown in the picture, and then part B shows the position. So I copied the graph, and this is the position. So the problem asks you, when is P, the particle, or whatever it is, the body, moving to the left, to the right, and standing still? Okay, so from 0 to 1, I'm going to answer parts A, B, and C all at once. From 0 to 1, the slope is +2. Positive, therefore the particle is moving to the right. This particle is moving right from 0 to 1. Kind of like interval notation when we did increasing and decreasing. It is standing still. Right here, the slope is 0. So the particle is standing still, whatever. I don't know if you should say standing. Not moving from 1 to 2. At 2, my slope is negative. So therefore, the particle is moving left. The velocity is negative. The velocity is negative. So therefore, the particle is moving left, and that is from 2 to 3. And that slope would be down 4, right one, -4. And then from 3 to 5, the particle is standing still. And then I should have covered this up, sorry. And then from 5 to 6, 6 is included. From 5 to 6, it's moving left because the slope is negative, and that is going to be -.